There is a number your browser hands over before you click anything, and it is one of the oldest identifying signals on the web. It is the size of your screen, not roughly, not rounded off, but the exact pixel dimensions of your display, the working area left after your taskbar, the size of the window you happen to have open, and how much of that window is actually showing the page. It sounds harmless. It is not, and today I want to explain why screen and viewport fingerprinting still catches setups that got everything else right. I'm Saning Korean in the 2 Street. Quick note on framing before I start. I run real proxy and cloud phone farms, and I spend most of my time on the hardware and environment layer of this problem, which is exactly where this signal lives. I am going to keep this third person and defensive the whole way through how the technique works and how it gets defended against, not a recipe for beating any particular site. And there are no undetectable promises here. Understanding this signal removes one more contradiction from a setup. It does not make anything invisible. So start with what a page can actually see. When a script runs, it can ask the browser a short list of questions about your display, and the browser answers all of them without any permission prompt. It can ask for the full screen width and height. It can ask for the available width and height, which is the screen minus the space your operating system reserves for things like a taskbar or a dock. It can ask for the color depth, how many bits describe each pixel. It can ask for the device pixel ratio, which tells it whether you are on a standard display or a high-density one. And separately from all of that, it can ask how big the browser window is and how big the visible page area inside that window is. That last pair matters more than people expect, so let me separate them clearly. The window is the whole browser, frame and all. The viewport is the part actually showing the page after the toolbar at the top and any scroll bar on the side. Those two numbers and the gap between them describe your browser setup in a surprisingly specific way. Samson step Hanlens. Now here is why any of this identifies anybody on its own. A screen that is 1920 by 1080 is the most common resolution in the world. It tells a site almost nothing. But fingerprinting has never been about one value. It is about the combination and about whether the combination is internally consistent. Take that same common resolution and now add an available height that implies no taskbar at all, a device pixel ratio that does not match any real display of that size, a window that is larger than the screen it supposedly sits on, and the viewport whose height is a perfectly round number. Individually, every one of those is plausible. Together, they describe a machine that does not exist. That is the whole idea, and it is worth saying plainly. Detection is rarely looking for a forbidden value. It is looking for a set of values that cannot all be true at once. Let me walk through the specific contradictions that come up most, because they are concrete and they repeat. The first is the window that is bigger than the screen. This one is almost comically common in automated setups. A script sets a window size for consistency and sets it to something larger than the reported screen. No human has ever had a browser window wider than their monitor. It is not suspicious, it is impossible, and it is trivial to check. The second is available space that never changes. On a real desktop, the available height is the screen height minus whatever the operating system reserves. On Windows with a taskbar at the bottom, that is a specific and fairly predictable subtraction. On a Mac with the menu bar and the dock, it is different again. When the available dimensions come back exactly equal to the full screen dimensions, that describes a machine with no system interface at all, which in practice means a headless environment or a spoof that only bothered to change the top-level numbers. The third is the pixel ratio mismatch. A high-density display reports a device pixel ratio above 1, and that ratio has real consequences elsewhere. It changes how the browser reports certain measurements. It changes which image assets get requested, and it correlates with the physical size of the panel. A setup that claims a high-density ratio while reporting a resolution and a set of measurements that only make sense on a standard display is describing two different machines at once. The fourth is the mobile that is not a mobile. This is the big one for anyone working across device types. A profile claims to be a phone through the user agent and then reports a screen that is far too wide, a viewport with a desktop shape, a pixel ratio a phone would never have, and an orientation that never changes. The user agent said phone. Every measurement said desktop. The user agent is the easiest thing in the world to change. So when it disagrees with the measurements, detection trusts the measurements. And the fifth is the round number problem, which is subtle and worth understanding properly. Real viewport heights are messy. They are whatever is left after a specific browser version's toolbar, on a specific operating system, at a specific zoom level, with or without a bookmarks bar. That leftover is almost never a clean figure. When a large population of sessions all report viewport dimensions that are suspiciously tidy, or when a single set of dimensions appears far more often than any real hardware distribution would produce, that cluster becomes its own signal. The setup did not look wrong on its own. It looked wrong in aggregate. That aggregate point deserves a moment because it is the part people underestimate. A site does not only compare your values against physics, it compares them against every other session it has seen. If a particular combination of screen, viewport, and pixel ratio appears across hundreds of accounts that otherwise claim to be unrelated strangers, the combination itself becomes the link. No single value was wrong, the sharing was. There is a sixth case worth adding, because it trips up people who are otherwise careful, and that is the multiple monitor situations. A real desktop user with two displays produces measurements that look odd until you know why. The window can sit at a horizontal position far beyond the width of the primary screen, because it has been dragged onto the second panel. The available area can reflect one display while the window reports a position on another. Those readings look inconsistent at a glance, and yet they are completely genuine, and a decent detection system knows the shape of that pattern because a large slice of real desktop users generate it every day. The interesting failure is the reverse. A spoofed profile almost never reproduces it, so an entire population of sessions that all sit perfectly inside a single display, always at a tidy position, is quietly unusual in a way that real hardware is not. Orientation is the same story on the mobile side. A genuine phone rotates. The width and the height swap. The viewport reflows, and the orientation value changes with it, and all of that happens together because it is one physical event. A profile claiming to be a phone that has never once rotated in its entire recorded history, and whose dimensions are frozen in portrait forever, is describing a device nobody is holding. So how does this get defended against, and where do the defenses fall short? The honest answer is that the good tools do not try to invent a display. They take a real, coherent hardware profile and keep every dependent value consistent with it. The screen, the available space, the pixel ratio, the window, the viewport, and the reported measurements all come from one plausible machine, and they stay that way for the life of the profile. That consistency is the entire job. The weaker approach is to randomize. A tool picks a fresh screen size each session, or adds a small random offset to make the value unique. That feels like privacy, and it usually is the opposite. A display that changes every session describes a person who buys a new monitor every morning, and the value randomized into a range nobody actually owns is more identifying than the common value it replaced, not less, because now you are the only session in the world reporting it. This is the trap that catches people who think of fingerprinting as hiding rather than as blending. There is also a category of leak that spoofing at the top level does not reach. Layout is measured, not just declared. A page can render an element, measure what it got back, and infer the real available space from the result. It can watch how text wraps. It can read what a media query resolves to. It can check whether the reported viewport agrees with what the layout engine actually produced. If the top-level numbers were rewritten, but the rendering underneath still reflects the true window, those two disagree, and the disagreement is the finding. This is the same lesson as the canvas and the web-GUI signals. The values a page derives from doing real work are much harder to fake than the values it simply asks for. Changing the zoom level shifts several of these measurements at once in a specific and related way. A setup that alters one of them without the others produces a relationship that no zoom level would ever create. So what does this mean practically? Defensively, for someone who cares about their setup being coherent, the useful frame is to stop thinking about any single number and start thinking about whether the whole picture describes one real machine. Pick a hardware profile that genuinely exists and is genuinely common. Let the browser report the values that follow from it rather than overriding them piecemeal. Keep it stable across sessions, because stability is what a real person looks like. And check the derived values, not just the declared ones, because the derived values are where the contradictions show up. The other useful habit is to actually look. These values are readable in about a minute in any browser console, and comparing what a profile claims against what the layout genuinely produces tells you more than any vendor page will. If a tool claims to handle this layer, that claim is testable, and you should test it rather than take it on trust. I test these browsers on real multi-account setups, and the written reviews and the picks I actually trust are all at antidetectbrowser.org. Nothing there promises anything is undetectable, because nothing is. What the reviews do is show what each tool actually reports and where it actually leaks. So the short version, screen and viewport fingerprinting is old, quiet, and still effective, because it is not really about your resolution. It is about whether your resolution, your available space, your pixel ratio, your window, your viewport, and your rendered layout all agree that they belong to the same machine. Tools that keep one coherent profile handle it well. Tools that randomize per session usually make it worse. And the leaks that survive are almost always the values a page measures rather than the values it asks for. Full written reviews and tested picks are at antidetectbrowser.org. And if this was useful, subscribe for honest, tested anti-detect browser reviews.